Here I'll assemble the jig for the first test of the AudioIO board. So we start off with a StickIt and insert a Zula 2 LX25 FPGA board into it. Take an AudioIO board, insert it into a PMOD slot, then loop the output of the AudioIO board over to its input and connect to the USB port on the PC. Now what we have here is that the PC will download a audio file, audio samples, into the SD-RAM on the Zula 2 board. That will send them over to the codec. The output part of the codec will send the output, will convert it into analog audio. It'll come back around, go into the input port. Codec will take that and convert that back into digitized audio samples, which will get stored back into the Zula 2 SD-RAM here, and eventually will be uploaded back to the PC. And then you can compare the what we sent down to what we got back and see if they match up or not. Now that I've built the hardware, if you consider plugging a few boards together to be building hardware. But anyway, now that the hardware is assembled, I'll go ahead and download the FPGA bitstream into it and run the test, and we'll see if it works. So I have the bitstream file right here, and I'll open up the program to download it into the FPGA and proceed. Okay, the FPGA is programmed now. Now I have a Python script that will generate sine waves in the PC, download those into the FPGA board, and run those through the codec and back into the codec again to sample the sine waves, and we'll see if what we loaded to go out resembles what we sampled when it came back in. So I'll double click that, and the program will run, and here are the results. And let me scale that to the window size. And it looks pretty much like not much of anything at all, because there are so many sine wave samples within this window. So I'm going to expand that out a little bit. We only need a few cycles of the sine wave to see if they match up or not. And there we go. We have the left signal, which is this one. The larger signal goes out the left channel and comes back in, and the smaller signal is on the right channel. And let me expand that just a little bit more. A couple of cycles only. And we have the output versus this is what we sent out, and this is what comes back in. This is what we sent out, and this is what we get when it comes back in. And we can see that the left channel and the right channel both pretty much resemble what they should resemble. Whatever's going out is also coming back in with just a slight shift in the waveforms. So that shows that the first audio test does work as we expected it to, or at least as I expected it to.